Now it's time for Bureau Veritas. Bureau Veritas is gold sponsor to DSM, and they are also one of the largest classification and certification societies worldwide. Bureau Veritas provides classification and certification of ships and offshore units. So we will hear about ship propulsion machinery running for the future greenhouse gas limits. And we will be listening to Marcello Zanotti. Please give an applause.
Thank you. So good afternoon, everybody. And I can see that, yeah, it should be a bit smaller, actually. The image is too big. And one of the main topics I've seen and listened during the morning presentation is the use of alternate fuels and LNG and other type of fuels. So today we're going to have a small introduction and presentation about the use of LNG and the last few slides about alternative fuels. So the part one will be about LNG as fuel and their environmental regulation, why using LNG, LNG related to safety, and gas propulsion design and bunkering of LNG. Before, two presentations before, we had a good, actually, presentation from a bunkering company for LNG. So, the decision of choosing a fuel is based on different topics. Fuel price, CapEx, and OpEx, so it means the money that the company have to invest to install new system and the operational expenditure. Emission limitations, so the regulation, the logistics, the flexibility that the fuel choice will give, and the sustainability of the fuels. And last but not least, the fuel price. So we have heard today already, we know that 2020 will be a milestone for the implementation of the regulation. And, excuse me, can you? No, okay. For the implementation of the regulation. And with the implementation also of new emission control area also in 3 zones in China, starting from 2016. So the restriction about emission, NOx, SOx, etc., are becoming more and more stringent, and there will be no further delay in implementation of new regulation. So we have 3 options. The main option now that we have is the use of heavy fuel oil, traditional heavy fuel oil, with exhaust gas treatment unit, like scrubber, the using of low sulfur heavy fuel oil, and treatment units when in European ports when required to go down to 0.1%, or the use of marine gas oil. Third option is LNG as fuel. So here there is a diagram showing, giving an estimation of the cost for the companies to establish, to use one of the 3 options. So, of course, the using of MRG, marine gas oil, is only as operational cost. It will require no changes in the ships. The cost of scrubber will require cost for implementation and installation of the system, but operational cost higher, lower compared to heavy fuel oil, marine gas oil, but still high. LNG in new construction or in conversion of ships will require higher cost for installation that will be gained anyway later in the operational cost that will be are estimated as the lower one of the 3 options. So the global and recent development about availability of LNG and infrastructure for bunkering has made now LNG really a main actor in using as fuel. here, just to mention that Tier 3 requirements, they can be reached with the use of gas, so LNG or other type of gas, or dual fuel engine that are running on Otto cycle. Other system, they need anyway different arrangement for comply with Tier 2 requirements. Tier 2 requirement is about NOx reduction. So the possible solution, as we said, is the use of low sulfur fuel oils, the use of LNG, or install scrubber and using heavy fuel oil. What's the advantage and disadvantage? All the three options has, of course, advantage and disadvantage. Let's see some about scrubbers. There is a need for continuous measurement and recording of the effluence of the sulfur content. There is the risk of water pollution when we discharge the water from the scrubber system, and the use of caustic soda as an agent, as a chemical add, when we use the system in a closed loop system. So operational requirements are quite high. Not need to mention that BV provide the guidelines on the installation of scrubbers. What are, on the other side, the disadvantages, for instance, of having LNG as fuel? The compliance with NOx Tier 3 requirements is only with the low-pressure engine. For high-pressure gas diesel engine, based on diesel two-stroke, needs an exhaust gas recirculation system, so additional expenses. There is a risk of knocking and misfiring in the engine, but of course the main engine manufacturer are developing on this, and this will be reduced and reduced again. And one of the biggest risks is the methane slip. What does it mean, methane slip? That methane, so LNG, is actually one of the worst gas for the greenhouse effect, much worse than CO2. So the risk of methane is that during some operation of the ship, we actually have methane slip in the atmosphere, losing some of the advantages of having LNG as a fuel. This could be during normal combustion, when stopping the gas operation and changing to dual fuel or starting and stopping the engine, and due to some tank design and operational, or during bunkering. With the development of the technologies, it has been estimated by a study run in the Netherlands that anyway, the saving potential using LNG as fuel in greenhouse emission compared to use of marine fuel is approximately 40 to 45% of reduction of greenhouse effect using LNG. So why LNG as fuel then? First of all, you cannot see the top of the line over there, but because there is a good safety record now. 90,000 cargo voyages since the early 60s. Total number of launched LNG over 525 SRU. I'm not going to go on with numbers. But basically, the LNG system and LNG propulsion has proved so far to be reliable and safe. The other thing is that other main actors, new with different type of ships, are turning into LNG as propulsion. For instance, MSC Cruises, that they will build new cruise ships with LNG propulsion, or big container company, like in this case, CMA-CGM. Bureau Veritas is one of the leaders in the order and delivery of LNG fuel ships of different size. Here, again, is on the top of the line. Here is the number of order ships with LNG propulsion up in 2017 up till June. So DNV has the biggest share of the market. And the total fleet and order book as per March 2017 is over 200 ships. and BV being the class market leader in 2017 for LNG fuel ships. And they all go from smaller one, tugs, to bigger passenger ships or cargo ships. Here is some example of the ships that are being delivered and LNG with LNG propulsion. This is actually, some of them are DONSO connected. So, which are the factors that so far have hindered the development of LNG as fuels? And why these three factors are now being reduced, and we can optimistically look at the LNG as the fuel of the future. First of all was the uncertainty on dates of implementation regulation, and this uncertainty has now been cleared, so 2020 will be milestone creation of emission control areas, etc. The lack of LNG infrastructure and the lack of possibility of bunkering. This, of course, still an issue, but this is improving. More and more companies are investing in bunkering. We have a ship at DONSO port now called Corallius that is a bunkering ship for LNG. And uncertainty about the cost of LNG. Will it be convenient in the future to have LNG, or the price level compared to marine gas oil, heavy fuel oil will not give any advantage anymore? So far, for time being, LNG is still the most convenient fuel. And probably in the future, being the availability of LNG as resources, this will not change. In this map, you can see in green the infrastructure already available for bunkering, and in red, infrastructure that are under construction or will be developed soon for bunkering LNG. So, as you can see, key ports will be covered by the possibility of deliver LNG, of bunkering LNG. This scheme here just provides a short comparison between the three options, heavy fuel oil, low sulfur, heavy fuel oil scrubber, and LNG, and the problematic. So, for LNG, we can say that there is no area of caution. Like heavy fuel oil, low sulfur is not always available. It's not everywhere available so far. And there is always a big fight because the company are not ordering low sulfur, heavy fuel oil, so the manufacturers are not producing it, and that keeps the level high. But LNG has no caution area so far, as per our opinion, of course. So both in product availability, bunkering infrastructure, environmental effects, technological risk, and impact on ship design. Of course, there will be an impact on ship design, but well known. Operation, maintenance, and cost of the operation of the unit, and the price of fuel. None of these areas are actually critical. So, let's see what's the rules behind, what type of rules are behind LNG as fuel. First of all, IMO regulation, the IGF code from 2016, BV rules that has developed their own rule notes 529 for the use of LNG as fuel, and then, not mentioned here, but in the following slide, IGC code and SOLAS, of course. What's most important, what's the base of this, is that the safety, reliability, and dependability of the system shall be equivalent to that achieved with new and comparable conventional oil fuel, main, and auxiliary machinery. So the scope of all the rules is that the use of LNG as fuel must be as safe as the traditional system. This is the aim of the rules developed. I will skip this and go in this is some of the type of LNG tanks that could be installed according to rules on board ship. We go from independent tanks to integrated tanks. The most common is Type C tanks so far, so pressure above 2 bar with no secondary barrier. Other meaning is, of course, also in use. Here we can see 2 examples of installation of an LNG tank Type B, so integrated tank on a bulk carrier. Here is 2 types of tank on a very large oil carrier with one tank Type C and one tank Type B. Most important when addressing the development and the project, the design of an LNG fuel ship is the position of the LNG tank that is done according mainly to avoid any risk in case of a collision. And this system is developed with a probabilistic approach and developing rules based on experience and actual design. One of the latest projects developed by BV is a tags with LNG propulsion. A few words about this. Why tags with LNG propulsion? This is for a refinery in Norway, so very difficult environment. It's important because it's the use of tags usually in the port area requires more and more that they are environmentally friendly, so no pollution. And installing a LNG system on a tag is a challenge that was actually really well succeed with these tags called packs. Let's go further. Bunkering process. Through the year, we have gone from delivering bunker on LNG ships from truck, from terminal, and more ship to ship. This will be the future of delivering LNG. Which are the minimum performance required by a bunkering unit? It must be equipped with an effective transfer system able to reach maximum number of different type of LNG system. So, flexibility. High maneuverability, of course, is a bunker barge. The handling of the boil-off, so there will be a boil-off during bunker operation, and capability to deliver nitrogen for purging the lines. And in addition to this, now under developing is the CMOS specification. CMOS means the capability to do simultaneous operations to save time in the ship operation. For instance, a cargo ship, can you imagine a cargo ship having to stop the operation to do bunkering? So having a risk analysis in order to be able to bunker the ship during cargo operation. There are under developing bunkering guidelines to define how the procedure from bunkering, the definition of safety zone and security zone, so zone of the operation area that are sensitive to the bunkering. And ISO development on standardization of the equipment, LNG analysis, so fuel analysis, and standardization of the engine equipment. The last part, in 1 minute, just few other alternatives. One is the use of ethane, and we have some example of ship delivered with ethane, and I go directly. So Ineos has delivered a ship, they are ethane carrier, and they have developed, together with the engine manufacturer, the use of ethane as fuel, and together with the ship's flag, in this case it's Denmark. And this gives more or less the same result as using LNG. Of course, ethane is difficult. If you're not an ethane carrier, it's difficult to supply ethane as a bunker. Other option is methanol. Methanol presents some problem. Again, availability is low density compared to diesel, so it's used in a traditional diesel engine or in a specially modified diesel engine. It's toxic. It has a really low flash point and require a perfect cleaning on the tank and handling system. This is 7 ships delivered in Korea and Japan with methanol that already have 4,500 operations using methanol. The last system, and then my time is over, is use of LPG, so liquefied petroleum gas, as bunker. And they are, I'm not going into details, modification that would be required on the engine that have been studied by some of the main biggest engine manufacturers. That's it. If you have any question, thank you.